So here we are on the main screen where I've placed two gears, much as you would with Gearotic or Ticker in previous versions. If you look up here on the menu, you will see that there are 12 commands under the objects list. These 12 commands comprise most of the controls you'll use for building any sort of mechanism within Ticker. Now, I can't guarantee that the list won't increase, but as a matter of design criteria, I'm trying to keep it as minimal as possible. As you can imagine, these first 6, spur, worm, helical, bevel, planetary, and timing pulleys, do exactly as the word implies. They'll simply put objects on the screen, much as I have here. The 7th one, assets, allows you to load shapes that were either included in the release or that you've designed and imported yourself using this button over here, create asset. The rest of the buttons have multiple purposes, and they activate based on the context of how you've asked them to proceed. As you can see, it's a pretty lean menu. So let's compare ourselves to Gearotic at this point. I have two gears on the screen. One is 20 teeth and one is 10 teeth. The selection of these gears, incidentally, when I click, you'll see it has the number 1. That means it's the first one I've selected. Should I push the Shift key and click on another gear, it will have the number 2 written on it, and so on up the line to 4. Up to 4 gears can be selected at once in most circumstances, and it is the selection of the items which set the context for some of these other buttons. Let's take a look at what happens if we go to the simulation screen with the tab at the top. You can see that there's only 4 or 5 buttons here. The rest are checkboxes giving various display options during your simulation. If we push Run, you can see the gears fall off of the screen. I'll stop the simulation, and whenever you stop a simulation, you go back to your design screen settings. So we're back to our original. The gears are sitting in space. We have gravity turned on, as we can see up here in the corner, and this is the thing about a physics simulation. Normally you would have to lock a gear to something, like extend these shafts to the workbench, or some way to lock a gear in space. In Gearotic, we didn't have this kind of problem. No shaft could move in Gearotic, so this gear could not go around this master gear. This was 1 degree of freedom. In Ticker, you have 6 degrees of freedom per gear, 12 degrees of freedom for any 2 gears in terms of how they can relate to each other, and this complicates things quite a bit. We don't want, however, to hit Run and see them flow off. So Ticker implements something that I call conversational physics. It keeps the physics to a level that you'd expect it to be so that you can play around with various aspects of your mechanisms. So when you put a gear on the screen, normally this property position lock is set. If you're not attached to anything and you have position lock set, the system knows that you really don't want it to move around. So when we hit play, you can see we're now simulating with gravity on, and yet they're not moving, nor are they rotating. In Gearotic, when you first placed the gear, it was given the title of master, and the master gear had a motor attached. In Ticker, any object can have a motor. So if we want to see motion, we'd have to click on a gear and click the property has motor. If we give it a motor, we can see that now we have settings such as motor's power is currently on, what the RPM you wish it to be at max, and what the ramp time is. Also a direction and a motor force. These are all set by default. You can now hit Run, and as you can see, the gears are rotating. If I click on a particular gear, up here in the right-hand corner, we'll see an RPM. Currently, this master gear with the motor is going at about 10 RPM negative, so it's going counterclockwise at 10 RPM. Since this is a 20-tooth and a 10-tooth gear, if I click on the second gear, you can see it's going twice as fast, 20 RPM, in the opposite direction. Now you might have noted that when we selected this gear and started, we asked for 100 RPM, not 10. The reason that it's going slower is we have 2 ways to control time within Ticker. The first is a global motor speed control, which is up here under motor scale. At the moment, we're set on a low motor scale, approximately 10% of max. So the first gear will go 10 RPM, even though we've requested 100. To show you what I mean here, we can see it's currently going at 10, but if I slide the motor scale all the way up, the motor now is going 100. But As far as a display, it's hard to see exactly what's going on. Even at 60 frames a second, you begin to see some warped effects and almost like looking at a wheel on a car. So most of the time I'll run my simulations at a low motor scale because it's simply setting the maximum speed that I want that motor to go during the simulation. The second control of time is one over here called time scale on the right hand side of the screen. This is slow motion mode basically. The two are not really related, although you'd think that they are. When you're going at a motor scale, you're actually turning at that speed, and your forces, torques, and the various forces involved are all related to that speed. If you slide the motor scale up, your torque increases, the forces increase in power, and that all feeds back into how your simulation runs. Time scale is different. It slows down into slow motion the simulation so that the same torques and forces are involved, but now you can see exactly what's going on in a very low, very slow time scale. You can slide this between 0 or 1 anytime during a simulation. It has no effect on forces or torques or anything of that nature. Now the problem with a simulation is, though most people would like to play with a physics simulation, they really wouldn't like it if it acted as it should in the real world. As an example, let's turn off the position lock of the second gear. So now we're no longer telling it it's locked in space. Gravity is still enabled, and in real physics, if I were to start a simulation, the second gear would simply fall off into space. That's not what's going to happen in Ticker. It's going to fall all right, but it's going to sink down under gravity to the bottom of that gear. This is what I call conversational physics. Physics, yes, but keep it realistic to building a simulation that you wish. This is pretty much the equivalent of having a link between the two objects. And if it makes one feel better to see that link, we can stop the simulation, go back to 3D models, and look at our 8th button called Links. Links does different things depending on how you've selected items. In the case of selecting 2 shafts, it will create a link. So if we click on the first shaft, we can see that it has changed color and has 1 hearts on it, although you can't see them because they're on the side. And then we hit the shift button and select our second shaft. It's now number 2. If you have 2 shafts selected and press the links button, you'll be presented with a link. And that link has been placed between the 2 shafts, and the shafts have been extended so that you can place the link wherever you want on the shafts. Also, up here in the left-hand corner, there is a button to adjust the thickness of that link. In future, there may be more buttons, but some of these functions I've roughed in to work the way I want them to work, and I've left prettying them up until later on. If you look at something sideways, you'll be able to judge basically where you're putting it. Again, this program is not meant for the exacting specification of CAD. It's meant to place things where they look good to you. You click accept, and now you have a link. So now one can feel better about the simulation being conversational when you see what happens when you hit go. Now, something complex happened here, and we need to discuss that. This first gear, the master, I've locked in space by checking position lock. The second gear does not have a position lock. The link itself is also an object. It has position lock checked, and it really cannot be locked in position if you want it to swing around. The center of this link is by definition the center point between the 2 poles in this particular case, which means if we lock in position, we'll have an invisible point in space locked in space at that position. So we have to unlock a link. And then let's try the simulation again. Something different again happened. Here you can see, when you think about it, we now put a bunch of weight on the front of these 2 shafts. We've locked the master shaft in position, but that only means a small point, infinitely small in space, at the origin of the big gear has been locked into space. So when we hit simulate, gravity both pulls the link down, this gear to the bottom, and things swivel on their orientation. It's a proper placement in terms of simulation, but perhaps not something you want to go on during a simulation that you're playing with. In order to stop that, we have a secondary override called orientation lock. If any of the gears are locked in orientation, they will all by default be locked in orientation, because if one gear can't tilt, neither can any of the other gears tilt, as long as they're all constrained in the same train. So this means that it now works as one would expect in a physical simulation. We hit go, gravity pulls it down. Now this is something else that needs to be considered within the context of a simulator. In Gearotic, we knew that if a 20-tooth gear was controlling a 10-tooth gear, the RPM would be double. In the case of ticker, if you don't have gravity enabled, for example, you're on a table, you can see what happens is that the forces of friction and torque cause the second gear to go around the first gear. This definitely affects RPM. As we can see looking at our RPM for the first motor, which is now at 15 because we've moved to motor scale. If we now look at the second motor, it is 18 RPM. A definite difference from the 2-to-1 normal that you would see. But this is because the second gear is now going around the first gear. So the lesson here is don't necessarily rely on RPMs to try to figure out what your ratio is going to be if you're playing with a piece of kinetic art. I'll stop that. Now you're always free to change any of the properties of any of the devices as whenever you're not in a simulation. You can click on them and change a great many things. If we want the motor to go faster, we can click it faster as a normal and things will go. There are some settings under the physics which you can set if you click the expert button when you have something selected. You can now change the mass of an object, the connection ERP. An ERP is simply an error correction speed. If two objects are not close enough together and the conversational physics determines they should be pulled a little bit tighter together, that connection is done by this connection ERP. It tells us to fix it at a rate of 70% of error. That keeps things smooth. Same thing with alignment, rotation, gear to gear. These are things that you shouldn't normally have to worry about, but as you get advanced, you may find that they can keep your simulation running without the dreaded singularity, which we will discuss later. We have rolling friction, angular damping, anti-ISO friction, and restitution. These are terms that you don't have to know, but we'll talk about them later so that you can control how maybe something bounces off of a simulation. Normally your expert mode would not be checked, just to try to keep up with the main design of the program, which is to be simple. There's not much here for you to check, and therefore not much that can screw up a simulation. This allows for a fast build and for you to have more fun with it. Now, when it comes to placing gears and so on, there's another way rather than recreating. If you already have a gear on the screen, you're free to select it, and on our 3D model screen, you can select Copy Selection. This is under the Tools and Utilities. There are very few tools and utilities. Copying is one of the handy ones. We click Copy Selection and we'll immediately go to a placement screen. You can see up here we're getting messages that tell us how to control the interface. You can ignore them once you've memorized them. So we're trying to select now. It's asking us to place the gear that we just placed. And we can do that by clicking on the screen and placing it somewhere else. We don't have to focus on one mechanism. We can build two half mechanisms at a time and join them later if we wish. Or we can click on a shaft and simply place the gear on the shaft where we wish. You can flip a gear's orientation. There are some bugs in that system that I'm working on, so I would recommend staying with the same orientation at the current or at this point in time. Once you accept something, everything resets itself back into position. These shafts will automatically size themselves correctly in terms of length. We don't worry in Ticker too much about the size of a shaft in terms of its diameter. When you go to CAD to finally design your machine, it's assumed that you'll take care of that. You can, however, click on a shaft and then change its size and orientation at a later point in the program. There are very few controls for a shaft when you look at properties. You can override the minimum and maximums of the shaft and therefore make it longer or shorter should you need to. You don't normally need to. You can override either direction so that it gets longer in the other direction. This takes us on a short journey to the 11th button, Objects Align, up here under Objects. The 11th menu item has several uses. One of them is to adjust the diameter of a shaft. So if you click on any shaft, such as that one, go to Objects Align, a menu opens up allowing you to change the radius of that shaft, and you can change it in real time to look as good as you want on whatever asset that you've imported. We hit accept, and that shaft is now that size. We should talk about shafts a bit more because they are pretty central to the program. When I began Ticker, I couldn't imagine what the interface could look like to make it simple to keep I didn't want to rewrite AutoCAD, I just wanted a simple utility for building kinetic art. So I decided that using a shaft paradigm locks everything into a context, which makes it much easier for me to place objects on the screen and manipulate them without worrying about 100 menus telling me specifics about orientation and placement that you want to make. As a result, shafts are the only known in my universe. All shafts are made with 0, 0, -1 as their orientation to start with. They're all designed that way, and therefore I can reference anything else to a shaft when I know that. So when you import objects, you'll see there's a special routine which basically tells me where up is in your STLs. So you'll notice that we've stayed in the air for most of these examples, and that's because I wanted to illustrate a lot of the forces that are involved. But you don't need to be in the air. Selecting any shaft and pushing the fuse button will fuse it down onto the work table. And at that point, you no longer need to have position lock checked for a gear that's on a shaft, which is fused onto the work table. Using such a gear, I've just turned off the position lock, and you can see that it stays where it is. This gear that we placed up top is also position locked, which is why that device didn't just rotate to the bottom, such as this. Now, shafts can be unfused simply by selecting them and hitting fuse again, and it'll go back to where it was. Therefore, you can lock things in place and unlock them at will. There is methods for attaching them to other devices. For example, if you want to place a shaft on an object, you hit the Place Shaft button. You can see it's asking me for a shaft diameter. Again, shaft diameters are kind of arbitrary in Ticker, but you might want them there just to look good. Now, you could pick anywhere on this screen and lock a shaft on the work table, or onto one of these gears, or even onto the side of one of these gears if you wish. We'll accept that. And now you can see there's a shaft sticking out of the side of this gear. If I were to copy this pinion now, we'll go back to 3D models, copy selection. If I touch that shaft, I can bring the gear out, and you won't see the gear for the moment, but it's on that shaft. And if I say accept, the gear is now on the shaft. And now if we try to simulate, you'll see something very strange happens. And this is because the gear that we just put on is locked in position. So we've come up with a conundrum where whichever gear has the most power tends to be the one that stays where it is. If we unlock the position lock on that, we fall off into space, of course, because we were locked to the table with this gear, but we unlocked, and when we locked it to the table, I turned off the position lock. So we need to have the position lock turned on. If we do that, now the gear that we added acts properly. And that's the thing about Ticker, is you want to be constantly trying to figure out what you've got locked, what you don't have locked, and what the actual physical forces involved are. If you come up with problems where something won't move, it's probably because you've checked lock position, which is a false constraint. In the end, when you're building your machine, if it's properly attached to ground, you won't need to lock position or orientation in any gear. But those two selections are available to make things comfortable for you as you go along. There is no limit to the level of complexity you can add to that in terms of adding shafts. If you wish to add another shaft, place shaft, we can place one on the side of this gear as well. You'll see when I'm placing things, a lot of times the other gears in the area will go transparent. This is to aid you so that you can see things a little better. Now, when you place a shaft onto something, you can see that there's a little, I don't know if it shows up in the video very well, but there's a little plane here where you can correct and shift on and off of that plane. You'll always be on the oriented plane of the point that you selected, but you're free to step it offside. Now, you could say that's not actually attached to the object, but in reality, if you were building a device, it would be trivial to build something that went around the collar of this gear to hold that shaft. So who am I to tell you you can't do that? So in this case, you could lock that shaft there. At times, the program will underestimate where it is. Double-click will take you back to an overall view. So the shaft that we just locked onto this gear, you can see it's sticking out at the side. And the program is assuming that you have some way of making that a reality. We could now copy that gear if we wish and move this gear up the shaft and accept. And again, you would have to release the position lock on that gear if you wanted it to behave in a mechanical construct. We'll go to simulation, and there we go. Now, forces can build up which are much too powerful for the masses and the selections that you have. And if you were to do that, your device would fly apart in 1,000 pieces. That's what's called a singularity. So every once in a while, or every gear that you place and every selection you make, it's a good idea to try a simulation just to make sure that you're not about to hit a singularity. Now you notice these are reacting quite well. There's no problem there. Let's turn a motor onto this gear here and see what happens if we do that. Now the motor that I just turned on the selected gear has to fight against the centripetal forces and the torques that are being provided as it goes around. So the RPM can vary depending on how much force I've given that motor to deal with. And you'll see it speeds up and slows down. And if you give it careful thought as you watch it going around, you'll realize that's quite realistic in terms of the weight swinging into itself in various spots. If you want to exemplify that, we can go to expert mode on the gear we just added and increase its mass. We'll have a talk about masses, units, gravity, and so on in the next video to give an idea of exactly how those things work. We don't deal with realism here, so I'm not dealing with pounds, inches, kilograms, and so on. I shouldn't even mention pounds and inches. This program is completely metric. There is no imperial measurements anywhere in it. It just makes it much easier to deal with, and most of the world is in metric. I don't think that most people even who deal with imperial systems will have a problem with that. Well, I think for now, for this video, that's enough. It's long enough and enough to for a person to digest. In the next videos, we'll discuss some of the further options and the contextual ways we can put things together to build a contraption using various shapes. Thanks for watching.